So just starting with the GNSS basics again. So what does it do and how does it work? At a very simple level, GNSS uses precise timing to determine a location. GNSS, if you haven't heard that term before, is an acronym for Global Navigation Satellite System. How it works essentially is we have satellites in orbit around the Earth, and we know those positions, and they're just sending out timing signals. And so what happens is we have a GNSS unit. Typically, it's an antenna and receiver. An antenna and a receiver. Sometimes they're integrated systems. So if we look at something like an R10 and R12, where it's one single unit, it's got a receiver and an antenna built into one another. This photo we have here is a GNSS antenna with a cable running to an independent receiver. So there's a few ways to collect the data, but really what we're doing is just collecting those timing signals from the satellites and then using that to determine a distance from the satellites, and then from that a location. So in a little bit more detail, what happens is the satellite is sending a signal with a timestamp. The timestamp includes the time that the signal was sent. The GNSS antenna then collects that signal and records when it was received. So we have a time 1 and a time 2, which gives us a difference in time. We can then use the speed of light because the signals travel at the speed of light. And so we can multiply our time by the velocity to get the distance from the satellite. Given enough of these satellites and variables and distances, we can then solve for the X, Y, and Z position of the antenna. So visually what that looks like is we have a point at an unknown location. So here we have maybe our basin rover unit, or our rover unit, excuse me, that just has that antenna and receiver, and we want to know the location of it. What we can do is measure the distance from the satellite. So the satellite's in orbit and we have a known position there. From that, we can kind of measure again time 1, so the timestamp from when the signal was sent from the satellite. The timestamp time 2 from when it was received. That gives us that difference in time. We can then multiply that by the speed of light and get the distance from the satellite. When we do this with one satellite, we only get a distance from it. And so what that really looks like in reality is a circle or a sphere around the satellite that our position could potentially be in. If we think about the distances, we just treat those as a radius. And because we only have one single distance component, we can just extrapolate that into that circle or that sphere. To kind of get a more precise location, we can then add more satellites to the mix. So if we look at it in the two-dimensional example, if we had a second satellite, we end up with 2 overlapping circles. That gives us 2 points that our point or our antenna could realistically be at. In the real world, we always know that we're kind of measuring on the surface of the Earth. And so it gives us an idea of where we are in the first place. So when we solve for an equation with 2 satellites in 2 dimensions, or excuse me, if we're doing 3 satellites in 3 dimensions, we can kind of have an idea of where we're at, but we want to be able to solve this empirically without any guessing. And so when we add a 3rd satellite to the mix, we get 3 overlapping circles. And that only gives us 1 place that the antenna can be at. This is a 2D example. When we look at it in 3 dimensions, we have to add a 4th satellite to the mix because we're doing spheres. So when we have an XYZ location and overlapping spheres with 3 satellites, we end up with 2 locations that the spheres can overlap. When we add that 4th satellite to the mix, that's we can actually solve for the X, Y, and Z position, regardless of where we are in space. So at a very basic level, that's how GNSS works. We're using the timing signals from the satellite with the timestamp from when the signal was sent from the satellite, received at the antenna, extrapolating a distance, and then adding more and more satellites on top of it to get a more precise and mathematically determined location.